Hi, in this video we're going to be discussing integrals with secant and tangent in them. So, a quick review of what we already know about secant and tangent is that the derivative of secant is secant times tangent, the derivative of tangent is secant squared, and we have our Pythagorean identities, where tangent squared plus 1 is secant squared, and tangent squared by itself then becomes secant squared minus 1. So let's start by looking at an example. Secant to the 9th of x, tangent to the 5th of x dx. And to properly integrate this, we either want to get something in a secant squared form times something in tangents only, or secant times tangent in secant only. So we see that we have an odd power of secant and an odd power of tangent. So let's try to convert this into something with secant only. So let's pull out that secant x, tangent x, and let's see what else we have. So we have secant to the 8th of x, and this is tangent to the 5th of x times secant x tangent x, or secant to the 4th. Or this, secant to the 8th, tangent to the 4th, secant tangent. Now we know that tangent squared of x is equal to secant squared of x minus 1. So let's put it in there and make this replacement. So we have secant to the 8th of x, and we have tangent to the 4th. So tangent squared is tangent to the 4th, and so we have secant squared of x minus 1 all squared times secant x tangent of x dx. Now it's just a simple u substitution. If u is equal to secant x, then du is secant x tangent of x dx. And so by u substitution, we have u to the 8th times u squared minus 1 all squared du. Now we just FOIL that out, so we get u to the 8th times u to the 4th minus 2u squared plus 1. Distribute that u to the 8th, we get u to the 12th minus 2u to the 10th plus u to the 8th du. And by integrating, we get u to the 13th over 13 minus 2u to the 11th over 11 plus u to the 9th over 9 plus c. But remember that u is secant of x. So we have secant to the 13th of x over 13 minus 2 secant to the 11th of x over 11 plus secant to the 9th of x over 9 plus c. Now let's look at just the integral of secant of x. Now this one requires a little bit of a trick. So what we're going to do is we're going to put secant of x in the numerator and put it over 1. And we're going to multiply everything by secant x. Let's just slide this dx over, plus tangent of x. And of course what we do to the top, we have to do the bottom. So secant x plus tangent of x dx. And now let's distribute the top here. So we get secant squared x plus secant x tangent x all over secant x plus tangent x. Now, we might notice something about the relationship between the numerator and the denominator. The numerator is actually the derivative of the denominator. So we'll just make a simple u substitution where u is equal to the denominator. And so du is going to be everything in the numerator. So this gives us the integral of du over u, which, as we remember, is the natural log of the absolute value of u plus c, which tells us that the integral of secant x dx is equal to the log of the absolute value of secant x plus tangent x plus c. Okay, now let's look at the integral of tangent of x. So we know that tangent is sine over cosine. So we can just rewrite this as sine of x over the cosine of x. And now we can just use a simple u substitution where u is equal to cosine. And so du is going to be equal to negative sine. And making that substitution, we have to first make sure that we have a negative sign for the du, and we'll balance it out with a negative on the outside. So this is negative integral of 1 over u du. And so this is negative log of the absolute value of u plus c. But u is cosine, so this is negative log of absolute value of cosine of x plus c, or just simply the log of secant of x plus c. All right, now let's look at tangent to the fourth, secant to the sixth. So we have an even power of tangent and an even power of secant. So what we can do is we can break up tangent and use Pythagorean identity, or we can break up secant and use Pythagorean identity. Now, since it's even, what we want to do is we want to pull out a secant squared. And so we'll have tangent to the fourth, secant to the fourth. And so everything has to be in terms of tangent. So secant to the fourth, so we know that secant squared of x. Now, if you remember it, that's great, but I can never remember it, even though I just wrote it down. But I know that sine squared plus cosine squared is equal to 1. And I know that if I divide everything by cosine squared, I'm going to get tangent squared plus 1 is equal to secant squared. So secant squared of x is equal to tangent squared of x plus 1. So we'll just replace that. So tangent to the fourth of x, and secant squared is tangent squared plus 1, but it's secant to the fourth, so it's squared squared. Secant squared of x dx. Now we just let u equal the tangent of x, and so du is going to be secant squared, just like we have here. This is du, and let's go ahead and color that, say, gold. And then our other part is going to be some function of u. And so when we do that, it's going to be u to the fourth times u squared plus 1 squared du. So we can go ahead and FOIL it out. So we get u to the fourth times u to the fourth plus 2u squared plus 1. Multiply it out, u to the eighth plus 2u to the sixth plus u to the fourth. And then we get, we can actually integrate it right from here. And it's just power rule plus 2 power rule plus power rule. And using our substitution that u is equal to the tangent of x, we get tangent to the 9th of x over 9 plus 2 tangent to the 7th of x over 7 plus the tangent of x to the 5th over 5 plus c. Now, for our final example, let's deal with a tricky one. So we have the integral of secant cubed of x. So this is going to be a trig integral by parts. So let's first break this up by, we'll have secant of x, secant squared of x. Now for our u substitution, we know the derivative of this guy, so we're going to let this be our u. So let's color this in copper. This is going to be our u, and the rest is going to be our du. So, or dv rather. So dv is secant squared, and we know what the integral of that is. That's just going to be the tangent. And our u is going to be secant, which tells us that du is secant x tangent of x. Now we just plug it into our formula. So we have uv, so secant x tangent of x minus the integral of v du. So that's secant of x tangent squared of x dx. Now, we can break this up, this guy here, and we can turn this into secant of x, and let's change tangent of x to secant squared minus 1. Okay, and we'll just bring secant tangent down. Now, let's distribute our secant. So we have secant x, tangent of x, minus the integral of secant cubed of x minus secant of x dx. And remember that this is equal to the integral of secant cubed of x. So let's go ahead and break up our integral. So we have secant x, tangent of x, minus the integral of secant cubed, minus the integral, or plus the integral of secant of x. And that's equal to secant cubed. Now, we have on the left side secant cubed, which is what we want to find, but we also have it over here. So let's go ahead and push it over. And so we get secant x, tangent of x, plus the integral of secant of x is equal to 2 integral secant cubed x dx. We know what the integral of secant is. That's the natural log of secant x plus tangent of x. And we'll have secant x tangent of x here. And this is equal to 2 secant cubed x dx. And all we have to do now is get rid of this 2. So let's go ahead, copy this, and move it down here. And we're just going to divide everything by 2. And that is the integral of secant cubed x dx. So the integral of secant cubed x is secant x tangent x plus the log of secant x plus tangent x plus c.